Woohoo! We're here with Math 40, and this is the chapters 8 and 9 practice test. Yay! So there are 5 problems on this test, and I've asked Sharktopus to come along to help us out. You'll probably want a calculator as well. And again, I've written it out on a PDF. But when you're taking the test online, you're going to want to have paper out. So just make sure you have paper of some sort, because these are not problems you should be doing in your head. I mean, they're problems that if you could do in your head, then that would be amazing and incredible. But there's really a good chance of making mistakes, I think. So, okay, so we're going to go ahead and get started. This is beginning in chapter 8. This is 8.1, 8.2, when we're just using bear math. So I should probably bring my bear to help us. The bear will help us. Rawr. And so here we go. I'm supposed to go ahead and simplify this radical. And inside this radical, I've got a bunch of stuff happening. I've got 288 x cubed, y squared, z to the 9th, and w. And you've got a couple choices. Those of you who have learned shortcuts will know that there are shortcuts you can use. But the other way to do this, which is perfectly acceptable as well, especially when you're just starting out, is to go ahead and break everything down. So in order to do that, I'm going to go ahead and break down 288. Now, off the top of my head, I don't know what goes into 288, but I know 2 does. And then 288 divided by 2 is 144. Woohoo! 2 times 144. And then I happen to know that 144 is 12 times 12. Now, here's the thing. You can keep going all the way down to the prime factors, or you could see that you have 2 numbers that are twins that can go running through the woods. That's for those of you who watched the bear math. If you didn't watch bear math, none of that's going to make sense. What I could say is you have a perfect square. So you could keep going, but you don't have to. So I'm going to go ahead and just stop there and have my 12 times 12. And then I'm going to write out my x's, x, x, x. I've got 2 y's. I've got 9 z's. So we briefly think, thank you, math teacher. What were you even thinking? And I would say, well, I thought that, I didn't want to make this too easy for you. Wahahaha. And then I've got a w. Okay. So the basics of bear math without too much drama is that you want to look for factors that match. So 12 times 12. And with bear math, you have the 2 12s go running. And the bear comes and eats one of them. Yum, 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 yum. And then you end up with a single 12 that gets out. For those of you who don't like theatrics in your mathematics, first of all, why not? But also, secondly, what we're looking for is perfect squares. And this is 144 is the perfect square of 12 times 12. So a single 12 comes out. Now, with 3 x's, I can only take 2 of them running. Does not matter which 2. They go running. Yum, yum, yum. And an x comes out. And then with the y's, 2 y's go running. Yum, 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 yum. 1 y makes it out. And now I already realize I've got kind of a mess. So one of the techniques is to either use a highlighter or simply to circle anything that doesn't run out of the cabin. Okay, so far I've got a 2 and an x that are hanging tight. Now with the z's, I've got 1 pair, 2 pairs, 3 pairs, 4 pairs, and they all go running. Yum, 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 yum. Yum, 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 yum. Yum, 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 yum. Yum, 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 yum. And then I've got 1 last z, because there were 9. If they're an odd number, 1's going to be left behind. And then the w's, there's only 1 w to begin with, so it doesn't get to go anywhere. So now I've got all the things that made it out, and then all the things that are stuck waiting to get rescued, the 2, the x, the z, and the w. And fun fact, believe it or not, this is kind of mathematical alphabetical order, believe it or not. It's really common to go X, then Y, then Z, then W. I know it sounds a little weird, but if you stick with math for a while, you'll get really used to it because it's the way we do it. Okay, and so I've got 12 and an X and a Y, and I've got 4 Z's, so I'm going to write that as Z to the 4th. And then I've got the square root or radical 2xzw. Okay, so there's my answer. Let's hope it's one of the possibilities up at top. So I'm going to need a 12. So it's one of these two. Those two aren't going to work. The 24 and the 6, those are red herrings. And then I've got an xyz to the 4th. This is x squared, so I know that's not right. 12xyz to the 4th, 2xzw, 2xzw. There we go. Now, the reason I double check instead of, if you can exclude 3, then just pick the last one, is to make sure it's kind of a nice way of checking to make sure I'm not completely off. If my answer is up here, then either I got it right or I got it wrong in a somewhat predictable way. So I'm feeling better about my work. Okay, woohoo! Let's go on to page 2. Now, since we're dealing with chapters 8 and 9, this is pretty much all gonna be radicals. So we got radicals, and then later on we've got some equations in the quadratic formula. I know it's very exciting. But here we're going to subtract radicals. So we're supposed to subtract and simplify completely. And I'll point out that I did, because I wrote these tests, I did put in an answer for folks who just hadn't read the section. Radical 20 minus radical 80, and notice that I gave you the option of the opposite of radical 60. So if you read the section, you know that's not the way it works. You have to add and subtract like terms. But that's just an example. We need like terms. So this is an example of sometimes I put answers in that I am anticipating some folks might guess if they haven't actually read and done the work. So, for those of you who have read and done the work, what we need to do is we need to simplify each radical and get it into lowest radical terms. So this first one I'm going to say is yellow, and the second one is blue. My two high contrast colors, because I'm going to work on them separately. So again, I'm going to be using bare math or whatever method you like to simplify radicals. And so I'm going to break mine down, and 20 is, let's see, it's 2 times 10 or 4 times 5. And then if I went with 2 times 10, then I've got 2 times 5. So inside my radical, I've got 2 times 2 times 5. I could have written it as 5 times 2 times 2. For this kind of work, the order is up to you. You don't have to make it look pretty. We're only halfway through the problem. And then I realized, oh, look, I've got a pair of twins, and so they can go running. And then the bear comes, nom, 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 eats one of them, and then one comes out. Of course, the 5, who is all by his lonesome, is stuck inside. So what we discover is that radical 20 is actually 2 radical 5. Okay, so let's work on the radical 80. Radical 80, for some reason, and I know because the movie came out just, a year ago, that this may give some people flashbacks, and I apologize, but doesn't Radical 80 sound like it should be from Cats? Like one of the cats would be named Radical 80, and he would do, or she would do, or they would do very exciting things. Maybe a little. Are you suggesting I've spent too much time writing tests and making videos? It's possible. It's definitely possible. Okay, 80. I'm just going to go 8 times 10. I know there are more beautiful, sophisticated ways to do it, but 8 times 10 will work. Then I've got 2 times 4, 2 times 2, and 2 times 5. Now, I have a whack ton of 2s, so I got to keep track of all of those. So I've got 1, 2, 3, 4 twos. 2, 2, 2, 2, 5. Okay, I got a pair of twos here. Yum, yum. Oops. Oh no, where's my magical it didn't happen machine? I love this. No, what? I didn't make a mistake. Okay, let's try it again. 2 twos. Yum, 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 yum. There we go. Yum, 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 yum. Okay. That's the sound of one of the twos getting eaten by the square bear. Yum, 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 yum. Okay, so I've got 4 radical 5. Okay, so that's my blue guy. Blue. I'm very tempted to start singing the bare necessities, but I'm going to try to have some self-control. So, next up, I need to rewrite this as, oops, let me come back up here. Radical 20, the yellow one, minus radical 80, the blue one. So I need to write the yellow one, which we know reduces to 2 radical 5. And I'm going to subtract the blue one, which we know reduces to 4 radical 5. And now they're like terms. They're like terms because their radicals match. You can't add or subtract things unless the complicated or different or thing that's not a number has to match. So like 2x and 4x, or 2 radical 5 and 4 radical 5. Okay, so I've got 2 radical 5 minus 4 radical 5. Well, if I had 2 and I took away 4, I would take away the 2 I had, and then I would owe someone another 2. So it's negative 2 radical 5. This one was not an easy problem. I mean, it looked easy. You know, you look at it, it's not. It's not very complicated to state. See if I can fit this all in. That seems very straightforward, but yet it takes a lot of work. So, you know, pat yourselves on the head. Nicely done. Okay, I've got a lot of options there. I've got negative 2 times radical 5, and I see that right here. Yay! And I know some of you are very excited because you can tell I've learned how to put the correct answer not always in the first spot. I know, I'm learning. Woohoo! You can teach an old math teacher new tricks. And, oh no. I have to be honest, a lot of people would probably leave this one to the end. Rationalizing the denominator is not a simple sort of problem. However, can I suggest that this one is not as bad as it seems? Remember that when you're rationalizing the denominator, that means you want to get the radical out of the denominator. And remember that when we're doing square roots, if you want, I mean, you could make it fancy. You can absolutely make it as fancy as you want. But if you don't mind a little cleanup on aisle 6, you can go ahead and just multiply by that same denominator. Because here, if I've got radical 12x times radical 12x, which I will write out here just in case anyone's confused about what happens, well, that's just 12x. Now, up top, you've got this. Okay. And then, now, a couple of things. Don't cancel the 12s. This is a 12 outside of radicals. 12 inside of radicals is a totally different number. Same thing with the x's. However, if we look up here, we see this answer doesn't appear up there. So what's going on? And the answer is, if you don't think hard about how you want to do it, you just go ahead and multiply by whatever's right there, you're going to end up having to reduce. So let's take a look at 12x, just the 12x inside the radical. Okay, 12 is 3 times 4, which is 2 times 2. And there's the kicker, 3 times 2 times 2 times x. Look at that. I got 2 twins who can go running. So let's get those out. The 2's go running. Yum, 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 yum. And 1 makes it out. And then I've got the 3x inside. So where I had 4 radical 12x all over 12x, I actually have 4 times 2 times 3x all over 12x. Do you see that? Let's see, I need another color. So this right there is this. Right there, that is that. You see that? So now if we look here, I got a whack ton of stuff that needs to be reduced, right? Because up top, I've got 8 radical 3x, and down on the bottom, I've got 12x. I can reduce this by 4s. So I end up with 2 radical 3x all over 3x. What do you guys think? Now, some people are asking me, wait a minute, couldn't we have reduced it right there? And the answer is you absolutely could have. You could have seen this and said, oh, I need to reduce that, and reduce it right there. So it's up to you. You guys are way smarter than I am a lot of the time. So, you know, if you see an opportunity, go ahead and take advantage of it. Let's see if I have cleverly put this answer up top. Have I? 2 radical 3x all over 3x, and I see it right there. Woohoo! Yay! Okay, and we're done with number 3, and we're only like 16 minutes in. This test takes a lot of knowledge and a lot of thinking, but the problems themselves, although complicated, not terribly time consuming. Now that I've said that, oh, this one's not the long one. Never mind. That was a terrible segue. I was segueing to number 5, which is the next one. Okay, you'll just have to remember it was a brilliant segue for a different problem. And I know it's kind of mesmerizing. I work next to a window, and I usually don't record in the afternoon because all the leaves make interesting lights happen over here. Okay, but we're gonna get through it. I thought it would be nice. I don't know if you can hear all the birds singing. You know, there's hope after math. The sideshow on the freeway. Oh yeah, life after math. Use the square root method to solve this equation and simplify. So I'm asking you for a particular method. Now, can I tell if you've used that particular method? No. However, that is the intention of this problem. So I'm going to go ahead and work it out that way. If I've got x squared minus 12 equals 0, so remember the square root method is slightly different than the quadratic formula. If we were using the quadratic formula, we'd leave it in this form. If we were using factoring, we would also leave it in this form and be very confused. But square root method actually asks you to move your constant away from your perfect square. And remember what we do here is we take the square root of the left and the square root of the right, and remember the trick for the square root method, you have to put a plus or minus out in front. You have to remember that when you take the square root, you have to consider that you could have a positive number to begin with or a negative number. There are 2 square roots. Okay, over here I get just x, and over here I get, oh no, I get something that yet again I get to simplify. Yay! You guys are going to be so good at simplifying by the time you're done. Okay, let's see. 3 times 4. 4 is 2 times 2, so this is plus or minus 3 times 2 times 2. The 2's go running. Yum, 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 yum. Now, do not get confused. They stick to the radical, right? So the plus or minus is first, then the 2, then whatever's left inside, which is the 3. See how that happened? The 2 came out but stuck right next to the radical. Don't put the 2 on the other sides of the plus or minus or you'll get confused. Okay, so I've got positive, looks like I wrote these out 2 at a time. So 2 radical 3, negative 2 radical 3, right? So a positive 1 and a negative 1. Let's look up here. Look at that. Yes, it seems that in trying to train me not to always have the correct answer be first, now I've always made the correct answer be in the middle. But, you know, I'm learning. I am learning. I'm doing my best. Okay, that's number 4. Now I'm going to ask you to remember that great segue, which I have already forgotten, but you guys are all amazed. Ooh, mind's blown. That was incredible. Wow, what an amazing video person. There we go. I became a teacher because I like to communicate. Okay, use the quadratic formula. Now, if someone tells you to use the quadratic formula, you want to use the quadratic formula. Generally, you don't want to try to go around. And in fact, you can take a quick little look down here and see that these answers are not simple. And so there's a good chance that factoring is not going to work. Just saying. Or perfect square. Now, if I say use the quadratic formula, could you use completing the square? Of course, you could. The quadratic formula is a faster way to complete the square. So you could do that. Notice how nice I am. I gave you the quadratic formula. Now, what did I not give you? I did not give you the part that says you need to get ax squared plus bx plus c equals 0. Remember, everything has to be on the left or the right if you want, and you need a 0 here. This is very, very important. So in our problem, 3x squared plus 2x equals 7, right off the bat, we've got a problem because we got to get the 7 onto the left side. Woohoo! Now we use the quadratic formula. A equals 3, b equals 2, c equals -7. That's really important because we had to move the 7 onto the left side. X equals the opposite of b plus or minus b squared minus 4 times a times c all over 2 times a. Okay, so let's see if we can make this look pretty. I got -2 plus or minus, and what's happening inside is 4, a minus, a minus. This is 28 times 3, which is like 30 times 3, which is 90, minus 3 times 2, which is 6, which is 84. Is that correct? Handy dandy calculator. 3 times 28 is 84. And I hear you asking, wait a minute, couldn't we just plug this whole thing into the calculator? You absolutely could. You absolutely could. So I've got this, and I'm going to go ahead and switch over here. I've got -2 plus or minus radical 88. Ugh, that is not a perfect square. However, what goes into 88? 4 goes into 88. So let's see, 88, I'm going to write up here, 88 is 4 times 22, which is 2 times 2, that's 2 times 11. I was going to try not to have to go to another page, but it looks like we're going to another page because I didn't want to try to write infinitesimally small. So here we go. We've got, this is number 5. We've got -2 plus or minus radical 2 times 2 times 2 times 11 all over 6. Okay, here we go. This is equal to x. So these two 2's go running, and 1 makes it out. Right, so these two 2's go running, and they make it out as a single 2. Okay, the whole thing's over 6. So I've got -2 plus or minus 2 radical, nothing else in here, so I multiply them back. And then I've got a question, which is, can I reduce this? So up top, are there any common factors? And the answer is yes, there are. I can factor a 2 out. So I can factor 2 out of this. 2 times was -2, -1. Plus or minus, if I factor out the 2, I'm just left with the radical. So I take the 2 out of both spots. And then I can cancel with the 6 and end up with -1 plus or minus radical 22 all over 3. Oh my goodness. Whew, that took a long time. And then let's go back up here. Can you see? You can kind of see both. -1. So it starts off with a -1. So we already know. Look at me trying to give you lots of options. Don't get fooled. Don't let me fool you. Oh, I took you to Smeary Town. Sorry about that. What? There's no smear. Okay, -1 plus or minus radical 22. So both of these have the same numerator. But what's the denominator? It's 3. Ah, so it's that one. And that, my friends, is the end of the chapters 8 and 9 practice test. It is totally time for Carnivore Tan's party. And I will say, I hope you have a great, wonderful day. It is a beautiful day on the day I'm recording this, which is why I'm hiding inside, because, you know, Heart of Darkness and all that. Creature of Darkness, I should say, and Heart of Darkness. Yeah, we did math teachers, cold dead hearts, you know, all that sort of thing. We're not allowed out in the sun. We would melt or burn up or something, I'm sure. But I hope you're out enjoying the sunshine. I hope you're out eating vegetables, living your best life, knowing that you're awesome and amazing. And, you know, math on.